Why, hello everyone! We're gonna have a little, introduction, just getting you started on these triangle proofs. So, a quick recap of how these proofs work. What's going on is you'll be given some information. You'll be given a couple of triangles, say they look like this. And then there's going to be some other given information for you. It'll be listed here, or it'll be on the picture itself. And what you need to do is you're going to list off the things that are congruent about these two triangles, and then hopefully you have three pairs of things that are congruent. So you got side, 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 angle, side, angle, and angle, angle, side. And if you have proven these three pairs of things are congruent, then the entire triangle is congruent, meaning all the other angles and all the missing sides are also guaranteed congruent. And that's going to be an important part as you venture forth into other proofs. They're built on this idea. You have some given information, you can make some conclusion about them, and then you can say something new about it that was previously unknown or unsubstantiated. And so we're going to use number 3 as our example. Or at least our first example here. I do want to mention there's like a lot of typos on this. For instance, even here on number 3, it says prove a triangle ABD is congruent to triangle DEF. This is not D. Like that's not D. This should say C right here. So just be aware of that. But go with what the picture has and go from there. So 3, the way our proofs work. We're going to list statements we know to be correct, and then on the right side, we're going to justify each of these statements, these conclusions we've made, based on, some sort of solid mathematical reason. And so here, our first one is that side AB is congruent to side DE. Well, those are congruent because it's already on the triangles, and it's listed in our givens here. And so in our reasons here, we're just going to put given. Ta-da! First thing. And then we can go and we need to make another statement about these two triangles. What's another pair of things that are congruent? Well, we got this side AC here, congruent to the side DF. And that's also listed here in our givens. And so we can put that. Side AC is congruent to side DF. Put a little mark there. And that is a given. And then we got one last given, BC congruent to EF. So I can put that here in my statements on the left side here. And the reason is it was given to us. It's on the picture already. It's actually listed in our givens. And so we know this side is congruent to this side, this side is congruent to this side, and then the final sides are congruent to each other. And so we now have 3 pairs of things congruent by these two triangles, and it's these 3 sides. Well, if all 3 sides of 2 triangles are congruent, then that lets you know everything else about the triangle is congruent. And so we can write out that the whole triangle is congruent. Triangle ABC is congruent to triangle DEF. And that's congruent by the side, side, side theorem. And so that's basically how these proofs work. It's a lot of filling in things, information that you know. And then why are the 2 triangles congruent? Side, 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 or side, angle, side, things like that. Well, this is like the easiest kind of proofs that you can do here, where all the information is given to you. Let's look at one where we had to make some conclusions based on other properties that we know about geometry. And so let's jump to 5. 5 has a little bit different given information here. It has AE bisects BD, and that angle A and angle E are congruent to each other. And so I'm going to come here and fill my little proof here. First statement already here, angle A congruent to angle E. Well, that was given to us. And then my next line, it says given again. Well, there is another given. It's this one here. AE, side AE, or segment AE, bisects segment BD. And that's important to know because that doesn't tell us 2 things are congruent, but we can conclude that 2 things are congruent because of that. So you do have to know what bisects means. Bisects means to cut exactly in half, not sort of in half, like exactly. It hits it at the midpoint. And so AE is coming through here. So BD is just hanging out. It's like And AE comes in and is like, take that! And it cuts it exactly in half. Well, if it cuts it exactly in half, that lets you know that these two parts are congruent to each other. And so I'm going to put that. DC is congruent to BC. And that's by the definition of bisect. To bisect is to cut exactly in half, so each half is congruent to each other, or to cut into two congruent parts. Okay, so we got that line figured out. And so right now we got an angle congruent and we got a side. We do need a third pair of things to be congruent on these triangles to prove that everything else is congruent about them. And we got this last one, angle ACB. That's this one here. And angle DCE. That's this one. Those are congruent to each other. Well, they are congruent to each other. Do you remember why? Hopefully with our previous little work here, you recognize that these angles in the middle are what are called vertical angles. And vertical angles are always congruent. And so we're going to put that. Vertical angles. Yep, vertical angles are always guaranteed congruent. And so we're going to put that in there. And so I got angle, angle, side, angle, angle, side. And so these two triangles are congruent by angle, angle, side. So there you go. So that's kind of a step up in the difficulty of what kind of proofs you can have. Yeah, so just realize, like, some of them are really easy. All the information is given to you, just fill it in. And then sometimes you have to make some conclusions based on some of the given information about the shapes and what was given to you, what was the information you started with. And so I want to talk about another one here, number 6, because we haven't seen this a whole lot yet. But when you see these two vertical lines, that means parallel to. And so this side PQ is parallel to ST, which is over here. So I'm going to put these little arrows here. That means those are the parallel lines. And I want to mention that specifically because when you get down here, where it says angle P congruent to angle T, that's these ones. We really haven't run into that a whole lot yet, but you're going to. Anytime you have parallel lines, and you have another line that crosses them, this other line is called a transversal. It comes through, and it cuts these parallel lines. Well, anytime you have parallel lines and it cut by this transversal, you create a lot of congruent angles. Specifically, these two are going to be congruent because they are what are called alternate interior angles. So I'm going to put that alternate interior angles. And you have a whole bunch of other things, like you do have alternate exterior angles, that'd be these ones. You have things called corresponding angles. That'd be something like this angle here and then this angle. They're in corresponding parts of these two intersections. Like these are both in the top left part. Or I could say these two are congruent because they're corresponding angles. So you have corresponding angles, you have alternate interior angles. You have same side interior, but those are not guaranteed congruent. They're just supplemental. But yeah, there's a whole bunch of different angles and they have different relationships with each other. But you definitely need to remember alternate interior angles and corresponding angles as we go throughout our proofs. So that's another thing that's going to show up. I'm going to leave the rest of this proof for you to figure out. I do want to jump to another one that's later on, number 14. We have some slightly different givens here. What I'd like for you to do is pause the video, see if you can complete the proof, and we'll check it. All right, hopefully you put in your givens already. You got AB congruent to DC, AB is parallel to DC, and that's a given to us. And then you got BC is congruent to CE. When you fill out your proofs, always start with your givens. Just, here's all our given information. Because from there, then you can start making some conclusions. So we have some corresponding angles. And this way, went over that parallel line stuff earlier. We have these parallel lines, and we have another line coming through here. Well, we need corresponding angles, and those are angles that are in the same spot or the intersections. So like these two are corresponding, or these two are corresponding, these two are corresponding, and these two are corresponding. We need to find a pair that's inside the triangles. Well, that's these two. And so I can put those two. I'm going to have angle ABC congruent to angle DCE. And yes, you have to use the 3 letters for those because angle C here, there's lots of angles at C, so you gotta use the 3 letters. So I did 3 letters on the other one as well. So yeah, hopefully you're able to capture that these two are congruent to each other. And if you look at your congruent parts, so we got 2 sides and the angle between them. We got 2 sides and the angle between them. And so these 2 triangles are congruent by side, angle, side. So that's what's going on with these proofs, at least for our first day. You're filling in these charts, just filling in the things that you can put, use the information that you have to further make conclusions. I did want to also remind you that when a side is shared, that's called reflexive property. They can say it's congruent to itself, so MO is congruent to MO. So we talked about vertical angles and reflexive property and corresponding angles. Yeah, those sort of things show up. So good luck on filling out your proofs.